A very good afternoon to everyone. On behalf of Nehru Planetarium, Nehru Memorial Museum and Library, I invite you all to the online discussion on International Asteroid Day. As we all know that June 30 is observed as International Asteroid Day. So to talk more on the subject and to spread awareness and to educate the public, the risk and the opportunities of asteroid and their impact on Earth, we are hosting this YouTube live session with two very experienced and young amateur astronomers and space enthusiasts, Mr. Siddharth Madan and Mr. Saurabh Kumar. Mr. Siddharth and Saurabh, I welcome you all. I'll welcome you both on this online discussion panel. Siddharth, Madan, and Saurabh are also involved very actively in many outreach programs organized by the Nehru Planetarium. So I welcome you both. All the young participants who are online present here are excited to know the detailed presentation on the subject. Thank you and over to you.
Thank you, ma'am, for that wonderful introduction. Now I'll share my screen. I hope my screen is visible. So, welcome everyone to this wonderful day of International Asteroid Day. My name is Siddharth Madan. Many of you were there, I hope, yesterday, and in our discussion where we discussed various aspects of universe and how the universe, came into being what it is now, and how the solar system formed, our planets formed. So today is Asteroid Day, as you already know. Let's begin with the first slide that I have to present here. As you can see in this slide, this is sort of a schematic diagram of our solar system. ये हमारे solar system का एक schematic diagram है, sort of. This is not up to scale, obviously. All the planets and stars are not the distance as depicted in this diagram, but in this schematic diagram, we can clearly see the locations as to the projected locations in our ecliptic plane of our solar system. This is something that I mentioned yesterday in our lecture, that how our solar system formed. Our solar system formed by the collapse of gas and dust, and it eventually collapsed into a single particular core, and which eventually became our sun. और उस सन की रेडिएशन प्रेशर की वजह से जो आजू बाजू जो डस्ट और गैस के क्लाउड्स थे वो they became they were pushed back. So hence all the heavy elements or the matter were in the inner orbit. So hence all the inner orbit planets are solid planets, and just for instance, Mercury, Venus, Earth, and Mars. So all these elements, all these constituent elements of our solar system are basically heavy mass objects and solid objects. And all the further beyond this asteroid belt, which is something that I'm going to discuss, all the further planets are made up of gases and stuff. And for instance, Jupiter, Saturn, Uranus, Neptune, ये सब चीजें gases से बनी है, क्योंकि gases हल्की होती थी और फिर वो eventually condense होके वो भी planet में form हो गई. And सब चीजें because of the angular momentum it gained due to the early universe perturbations, जो भी कुछ थोड़ी सी भी perturbations थी early universe के formation, early solar system के formations में, या due to certain supernovae around neighboring region of our sun, उन perturbations की वजह से जो भी planets बनते गए उनके satellites बनते गए, and then eventually these big and small stones, boulders, rocky like images sort of were suspended in the universe, in the solar system, in this particular region. This particular region could not form a particular planet, and क्योंकि वो वहाँ पे कंडेंस नहीं हुआ है एक पर्टिकुलर पॉइंट पे, और वो स्प्रेड आउट होता गया, and hence we call that particular belt asteroid belt. There is this Trojan boulders of small asteroids like meteor-like objects, which are also again solid. Over here, Greek camp, these Trojans are there. So basically, Trojan का मतलब ये होता है कि कोई ऐसी चीज, ऐसा कैरियर, जैसे ट्रोजन मैलवेयर भी होता है ना हमारे कंप्यूटर्स में, कोई ऐसा मैलवेयर जो हर जगह सॉफ्टवेयर के साथ कैरी हो रहा है, या कोई ऐसी चीज जो साथ में कैरी होती है। सो इस प्लेनेट के आजू बाजू आगे पीछे दे डोंट कोइंसाइड, मतलब क्रॉस नहीं करते हैं एक दूसरे का पाथ, अपनी जगह पे ऑर्बिट कर रहे हैं सन को, बट वो ऑर्बिट सेम है उनका। तो सिमिलरली अर्थ का भी एक ट्रोजन है, वो कुछ प्रॉब्ली कुछ 1000 किलोमीटर आगे चलता है या पीछे, आई मीन डिपेंडिंग ऑन हाउ यू perceive it. So, so yeah, these cannot be termed. There is no line as to what can be termed as an asteroid, or what can be termed as an meteor or something. Meteor हम उस चीज को बोलते हैं जो अर्थ के पास से होकर गुजरता है और हमें अपनी नेकेड आई से या किसी टेलीस्कोप की मदद से इतना ब्राइट हो जाता है कि वो अर्थ के एटमॉस्फेयर से लिट अप हो जाता है। एंड अगर वो अर्थ तक पहुंच जाता है, जब वो गिरता है, अगर वो गिर जाता है अर्थ के सरफेस पे, तो हम उसको मीटेराइट बोलते हैं। अगर नहीं गिरता, जस्ट सरपास करके चला जाता है, हीट अप होके बर्न हो जाता है, या तो उसको मीटियोर बोलते हैं। तो मतलब देयर इज अ वेरी फाइन लाइन बिटवीन व्हाट डू यू कॉल अ मीटियोर और एस्टेरॉइड और समथिंग। सो एस्टेरॉइड बेसिकली ये छोटे बड़े ऐसे पत्थर जैसे होते हैं, बोल्डर्स होते हैं, उनके वेरियस साइजेस होते हैं। एंड so this is something that I just mentioned in my description. And अब हम देखते हैं कि किस तरीके से साइजेस होते हैं इन बोल्डर्स की, इन एस्टेरॉइड्स की। सो बेसिकली प्लूटो इज अबाउट 2400 किलोमीटर्स इन डायमीटर, एंड ये कैरॉन उसका मून है, which is about half the size of Pluto, about 1200 kilometers in diameter. और जो सबसे बड़ा एस्टेरॉइड, या sort of we term it a dwarf planet, but it is there in that region of asteroid belt, which is called a Ceres. It's about 950 kilometers in diameter, and same goes for Vesta, Juno, and Pallas. Vesta is about 525 kilometers in diameter. You can see the comparison. This is 950, this is 525, and this is Eros. Eros is about 16 point something kilometers in diameter. So ये तो बहुत ही छोटा है, स्केल पे दिख भी नहीं रहा, but still it is there. It is a substantial sized asteroid. अब इस इमेज में जितने भी एस्टेरॉइड हैं, ये we have been over 1 million we've been tracking in this year, 2020, 2021. We've been tracking all the major asteroids, and until now we already know that there is no sort of hazardous asteroid that is going to impact on Earth, that is going to collide its orbit eventually. अब ये ऑर्बिट से कोलाइड कैसे होता है? जब ये कुछ ऐसे एस्टेरॉइड होते हैं जो मे बी दे कम क्लोज टू जुपिटर, या दे हैव सम कोलिजन इन बिटवीन दिस होल बेल्ट, कि वो अपना कोर्स चेंज कर लेते हैं, एंड जुपिटर की ग्रेविटी की वजह से स्लिंग शॉट हो जाते हैं यहाँ पे आके, ऐसे स्लिंग शॉट होके, एंड देन दे मूव टुवर्ड्स मार्स और मूव टुवर्ड्स अर्थ. आई होप यू कैन see the cursor of my system over here. So ऐसे they will collide, and then they will plunge like this and slingshot in a way, either they'll reach Mars or probably Earth, और Earth को pass by भी कर सकते हैं अगर if they're having that huge velocity. तो थोड़ा सा भी उनकी ऑर्बिट में अगर थोड़ा सा भी ऑफ सेंटर होगा तो it will just pass by, और अगर नहीं होगा तो it will eventually come. But all the major asteroids that we have been tracking, none of them is sort of in that hazardous sort of spectrum that we can call उस hazardous range में नहीं है वो. And इन सबको हम ट्रैक करते हैं just because अब हम ट्रैक कैसे करते हैं, ट्रैक क्यों करते हैं, उसका रीजन मैं आपको भी बताता हूँ. पहले हम ट्रैक करते कैसे हैं. So the first image here is showing the radar imaging. Radar imaging क्या होता है कि रेडियो वेव्स हम basically like all the planets, all the other bodies in our solar system apart from the sun, they don't have their own light source, right? They don't emit light in any other form. So we have to emit radio waves, which is also electromagnetic waves, radio waves हम emit करते हैं, and those radio waves when they interact with with that particular asteroid, वो वहाँ से टकरा के वापस आती है to the radar system जो हम receiving पहले transmission करते हैं, and then we have received the radio waves, and then we using radio imaging we estimate as to what that particular object looks like, and this is that particular GIF image of a radar image that we have extrapolated for an asteroid. और दूसरा क्या है मेथड? दूसरा मेथड है फोटोमेट्री. फोटोमेट्री क्या होता है कि in the background of all the stars that we can see from our place, we have all the images stacked one after the other, and if there is some movement like ये जो movement हो रहा है, this is a satellite. ये एक satellite है. Let's say ये जो glitches आ रहे हैं, if you can see over here, all these glitches are something that we can use with the help of photometry. We can discern the change in the luminosity of that particular star in the background, and with that we will be able to tell what would be the size of that particular asteroid, or वो asteroid whether अभी हम track कर भी रहे हैं या नहीं, whether हम वहाँ पे कुछ already observe कर चुके हैं या कोई नया object है. In a similar way, बहुत सारे asteroid नए discover होते रहते हैं. Famous Indian scientist बेनू बापू, उनके नाम पे एक asteroid है, और भी major eminent personalities like S. Chandrasekhar, उनके नाम पे भी एक asteroid है. So there are so many of these asteroids that if you want to honor a scientist or somebody, they will have to track that, naming it some scientific name A, B, something plus minus this thing, depending on उसका orbit कितना है and all. So और किस date को वो locate हुआ था. So then you make it a little in the honor of that particular scientist, उनके नाम पे हम we name it. So here are the major impacts that were there during the course of our planet. So the oldermost known impact is near eastern Australia. The size of that asteroid is estimated about 10 kilometers in size, 10 kilometers in diameter, sort of. And it was about 300 million years ago. So the crater and all, everything has, the dynamic weather system of our Earth has sort of depleted in a way. But yet, we are able to, see the remnants of that impact. And Chikutlu, ये बहुत different name है pronounce करने के लिए, but it is pronounced like Chikutlu impact. And this was the main impact for the extinction of dinosaurs, which is also known as that extinction event, Cretaceous and Paleogene extinction event. And it happened about 66 million years ago. It led to the extinction of dinosaurs. Or I mean, it's just a wonderful thought to imagine कि अगर ये ना हुआ होता, तो either हम humans जो sort of universe में अपने existence को rule कर रहे हैं, वो होते नहीं, और अगर होते तो we would be sharing our existence with dinosaurs. So what would have been the fate of our Earth in that scenario would have been totally different. क्योंकि उस समय में 66 million years ago, primates भी नहीं थे, monkeys भी नहीं थे, and there were only small mammals which were able to survive this basic holocaust that appeared, that resulted from this particular event. For 6 years there was complete darkness, dark cloud of dust and gas, and complete darkness, no sunlight, nothing. And hence all the major mammals and all the dinosaurs were, literally, removed from the face of the earth. So that event. So अब हम कोशिश करते हैं कि ये since now we are at the helm of representing the species of our planet, we are ought to save the fate of our planet from such impacts. So we have been pushing on various missions of our planet, saving and stuff. And One of the major impacts in the past recent contemporary times is this Tunguska event. And sorry, my voice is audible, I believe. Oh yeah. So this Tunguska event जो हुआ था ये जिसकी वजह से ही अ, आज का हम ये celebrate करते हैं. Sort of celebrate as in we try to spread awareness amongst individuals कि ऐसे भी कोई objects होते हैं हमारे solar system में जो कभी impact डाल सकते हैं हमारी existence पे. And this sort of creates a urgency in pushing up the technological advancements that we require to put forth these asteroids away from our planet, fragile planet. And the Tunguska जो asteroid था, it was about 100 meters in diameter, and it resulted in a huge amount of destruction. Destruction sort of landed in Russia. The destruction was of sorts of trees and vegetations and stuff. A few people died, but it has not been properly cited. But still, it was a major event, and about 5.0 Richter scale earthquake was detected in the nearby region, and it was a very sort of notorious event in that time, and people were like baffled that we seriously need to track all the asteroids because there is no such guarantee as to what will be the fate of our human species. And at the same time, ये कुछ पिछले कुछ साल पहले, about 8 years ago, Chelyabinsk meteor event occurred. Again, this asteroid or a meteor, fine line between the definitions. This Chelyabinsk meteor again struck around in the region of Siberia and again in Russia, and about 30 million trees were uprooted. And so, in order to you know block or be aware as to what these asteroids are up to, we need to not just track them, we need to have the technological advancements, we need to be prepared for the missions that we can send. We can probably send a heavier sort of spacecraft which can roam, orbit around that particular uh, asteroid to course correct its orbit, or we can send an impactor to completely dissuade it from its orbit, or we can position this missiles that we can send to attack it and disintegrate that particular asteroid. It's a little dangerous. These three are the major solutions that we are proposing. Scientific community have been proposing every now and then, and as soon as possible, we need to be aware of what the location of that particular asteroid has to be. उस एस्टेरॉइड की लोकेशन हम चाहते हैं कि जितनी जल्दी हम उसको ट्रैक कर पाए उतनी जल्दी हम उसको टैकल कर पाएंगे. उतने अच्छे सोल्यूशन है. सबसे बेस्ट सोल्यूशन यही है कि कोई ऐसा रोवर भेजे या कोई ऐसा ऑर्बिटर भेजे जो उसके ऑर्बिट को ही कोर्स करेक्ट कर दे और अर्थ तक पहुंचने ही हो. ऐसा नहीं हुआ तो फिर हम इम्पैक्टर भेजेंगे कि उस छोटा सा इम्पैक्टर होगा और उसके ऑर्बिट को डिसर्वे कर देगा टोटली. एंड तीसरा यही जो मैंने बोला कि तीसरा पॉइंट इज जो हम एक मिसाइल भेजेंगे जो उसको टोटली डिसइंटीग्रेट तोड़ कर देगी. और वो एस्टेरॉइड फिर थोड़ा सा डेंजरस इन द टर्म्स कि जो हमें ये नहीं पता कि किस प्रोपोर्शन में वो डिसइंटीग्रेट हुआ. कुछ बड़े छोटे पीसेस फिर भी रहेंगे एंड वो फिर भी अर्थ की डायरेक्शन में आ सकते हैं. इवन इफ दे सर्वाइव द एटमॉस्फेरिक हीट एंड दे हैव टू गो थ्रू. अगर वो सरफेस तक पहुंचे तो किसी मेजर ह्यूमन एस्टैब्लिशमेंट तक पहुंच सकते हैं, किसी सेटअप तक, सोशल सेटलमेंट तक पहुंच सकते हैं जहाँ पे वो बड़ा एक इम्पैक्ट बना सकते हैं, लोगों की लाइफ्स को थ्रेटन कर सकते हैं. सो दिस इज द लास्ट sort of resort for all of us. Now we will be focusing on what are the missions of Asteroid, and my colleague here Saurabh is going to present to you कि क्या ऐसे मिशंस हैं जो हमने अभी तक भेजे हैं या भेजेंगे इन एस्टेरॉइड को स्टडी करने के लिए. ऐसे उस एस्टेरॉइड के ऊपर क्या मिनरल्स होते हैं जो हम इवेंचुअली स्टडी करके उसको एक्सट्रैपोलेट कर पाएंगे इंफॉर्मेशन को, एंड ऑल्सो उन मिनरल्स को एक्सट्रैक्ट कर पाए फॉर आर फर्दर फर्दर एक्सप्लोरेशन। प्रॉब्ली कुछ ऐसे रेडियो एक्टिव मिनरल्स होंगे जो अर्थ पे नहीं हैं, जो बहुत एक्सपेंसिव होते हैं, उनको हम अर्थ पे ला भी पाएंगे। और फ्यूचर यूज के लिए अगर मे बी इफ देयर आर सम हाइड्रेटेड मिनरल्स, तो उसमें से हम पानी को एक्सट्रैक्ट कर पाएंगे, H2O को निकाल पाएंगे फॉर ह्यूमन यूज। Also, we will be able to, with chemical reaction, we'll be able to extract hydrogen to be used as fuel for further missions. So, all on that by Saurabh. So, I'll be switching on to Saurabh now. So, you
Yeah. So, should we take questions right now?
No, I think we should wrap it up and then.
Okay. Maybe afterwards, then we can take a question, right? Okay. Hello, everyone. I hope everyone is doing fine today. So, my name is Saurabh, and I work in the field of astrophysics and cosmology. So, as my colleague here, Siddharth, told a lot about asteroid formation and how things, these objects which are quite unknown, it come from an unknown realm. So, how these are formed, how these are forming, and how these were formed in the early stages when the solar system was very young, as in when it was just starting to form, when Earth was in, when all the planets were just forming, and how these asteroids sometimes can give us a good deep insight as to how solar system would have formed, the basic structure, the basic ingredients that were needed into this particular mission as to the whole formation stuff. So you need to explain this very elegantly. So I'll be taking on a different route here. So I'll be explaining more about the space missions which were sent by the astronomical agencies and space agencies such as NASA, European Space Agency, Japan Space Agency, and other space agencies all around the world to basically study these asteroids and learn as much as possible. To even help us, and also to sort of avoid collision if there will be any collision into the future, because this is actually something which is quite serious, and also this gives us an another edge or as to the tells us more about basic formation and the structure of the natural elements that are found in nature, and also the formation of asteroids actually helps us to explain the better formation of the solar system, because these objects, these are just the remains which were not a part of the formation of the planets and and the moons of other planets. So these are just hurtling all around the space and moving from one direction to another, always orbiting and revolving around the sun. So here I'll be giving a brief about the space missions which have been done in the past, and how these missions are going on, and how these missions are going to help us. What are the main objectives of different missions which were taken in the past? So these space missions are obviously are a journey to the unknown, because we really do not know much about these asteroids as to what's the origin. I mean, it's always speculated that these asteroids were actually formed in the starting time when the solar system was very young, around 4.3 billion years ago, when solar system was just starting to form, when the sun was in its very initial stages and all the material was in a nebula. So this was a whole nebula, a part of a nebula, and when the star was very young, when the sun was very young, when the planets were about to form, and these asteroids were the remains which were not a part of either the sun or these planets. So this is basically a step into the unknown. So the very first spacecraft which was taken to have a visit to these unknown worlds was basically Pioneer 10. It was a spacecraft which was essentially designed and essentially sent to study more about Jupiter in 1972. So it somehow took up very close pass with this particular asteroid in around 1972. So this was the very first close encounter with these unknown worlds. And the first dedicated mission which was done especially study the asteroids. So there was this spacecraft. This whole mission was called Near Shoemaker. So this was the first mission by NASA and you know the space agency to basically study an asteroid named Eros. So Eros is just part of the name. The whole name goes something like some numerical numbers, 4773 or 3779, some of these numbers, and this is how it actually normally goes. So this was this was this asteroid which was specifically chosen to basically study more about the asteroid's formation and what exactly these contain, and take up some close up pictures, because until that time, when when we did not know much about these asteroids, it's very difficult to get a grasp of these things as to how big they can be, and how near they are, what's the distance between those asteroids and the Earth. Is it going to collide on Earth or not, or is it going to take a close pass, or is it just going to fly by, right? So this was the first dedicated mission which was done for studying particular asteroid. So then the first spacecraft, which was another mission, which was especially another designed for an asteroid, was NASA's Galileo mission, which was basically which also took a flyby around an asteroid. It was around 1991, and around two different asteroids. So it was just flyby missions. So these sort of missions, which are called flyby missions, what happens to them, that they are actually made to study some planets or some different sort of these celestial objects, but somehow they took a close flyby with these objects such as asteroids, such as comets. So they take up some close-up pictures of these asteroids as to catalog them, because it's necessary to understand that what type of objects are actually surrounded by Earth, right? Because it's always necessary to I guess everyone is quite familiar and quite enthusiastic to watching these kind of movies, such as there was this Deep Impact, there was this Armageddon, and something like movies like Salvation series and the Expanse series, right? So these all are sort of movies which gives us an insight about into an imagination what would happen if we encounter an asteroid. So it's necessary to deploy as many missions as possible, and most of these missions, and mostly and for now, we have these robotic missions in which we send rovers which actually study these asteroids to know more about them, because it's quite important and quite pertinent to do that. So there are many missions which are currently in development by NASA, which is Psyche and Lucy, which is currently being deployed to study more asteroids. So, my colleague has mentioned about all these asteroids and size comparison. So here we have an asteroid named Benu. These asteroid Benu is quite a big object. It's around 500 meters long in diameter. So this particular asteroid is quite amazing. Why? Because we have a special dedicated mission to study this particular asteroid, which is called NASA's OSIRIS-REx spacecraft. So this was actually deployed to actually study this particular asteroid in 2018, and it actually collected a sample of dust and rocks. Now, this is actually this is quite pertinent. This is quite important as to understand the formation and collect these samples such as dust and rocks, because these are the relics, as we say, of the ancient times when basically this solar system was formed. So this is actually one of the main objectives that why we send these these missions, these robotics, these robotic structures, these robots into space, into asteroids, into celestial bodies, just to get a glimpse into this, glimpse into how these objects were formed and how solar system was formed, because these objects are millions and billions of years of old, and they basically contain those very samples, those very rocks which were formed in the very early stages. And when we have those, we can get into much depth understanding as to what were the elements which were required, and all sort of other minerals and natural sources. So here's a quick glimpse as to how this, how big these asteroids are. My colleague here shown a simple glimpse as to how, if I could just show you a quick glimpse as to how big these asteroids are. So here you can show a quick glimpse as to how big asteroids are by comparing it to a planet. So here there's this asteroid Vesta, which is quite small in terms of comparing to other different dwarf planets such as Ceres and Pluto. But here when we have this particular asteroid, which is called Benu, this is a quite a big rock, around 510 meters, in height, or in a diameter, and it is actually longer than the Empire State Building, which is stands in US, and then the Eiffel Tower. So this is actually showing how tall these objects are. Now, you may see, you may think that 510 meters is not very, not very long, not very big, but these are the kind of rocks which hurt us very much, because when these things, or even small asteroids, when they are passing by an atmosphere, sometimes these get burned up, into meteorites and stuff. But sometimes what happens that even small chunks of rock, they do not get burned up into the atmosphere, and these are not more than few centimeters of rocks, or a couple of meters, and they can cause a lot of damage onto the surface of Earth if impacted. So that's why it's necessary to keep a track of all these rocky objects which are surrounding by our Earth, because as you know, it's always necessary to keep precautions and to prevent anything which will happen. And this is just one of the reasons, just one of the reasons to study these objects. Another reason which my friend here must have told you about is basically to understand and what sort of minerals these asteroids must harbor, because it's quite a speculation that in early times, billions of years ago, what might have happened, that there might be some comet, there might be some asteroid which might have contained sort of water. This is just a speculation. So there might be some asteroid or comet which might have contained some sort of particles, some sort of icy things, and some sort of water which might have impacted on Earth, in the process of making dinosaurs extinct. But maybe it's in that particular process restarting life again. So this actually tells us a lot about these objects, because these objects can contain those mineral ores which we do not have on Earth, and also which might not even be periodic table, because right now whatever periodic table we have, they contain the elements which we know, right? So it's always necessary to keep an open mind and to study these objects, to always look for something alternative, because as we know that we have fossil fuels, right? We have these natural resources which we are continuously burning off, and we're using it in a very very huge way, and we are sort of making them, we are basically exhausting them, and it's quite important to look for those alternate resources, alternate sources of fuel to to help us, and not only help us, but to even help in the space exploration, because there are several ideas which are being which are being talked in NASA, and in Japanese space company, and even in India, in ISRO. So they are sort of trying to use these asteroids as a small station, like when we go to some particular when we are going to some particular place, we travel either by bus or sometimes by metro. So every time we have some station, right? So those stations are like some stops where you can refresh yourselves, or even you can fuel your vehicle and all sort of stuff. So these asteroids can act as those stops, because the fuels is fueling a spacecraft is quite important, and it's not always easy to actually give the fuel, to basically transfer the fuel from the Earth to the space, because it is quite risky process. So it's better to look for those fuel sources into space itself. So these asteroids can help into that domain, and create some sort of hardware, some sort of big man-made a structure to have that as a stop. So that's how these asteroids can act as these stops. So obviously we can have more than one way of using those asteroids, not only just keep away from Earth, but also to help us doing learn more about these minerals. Okay, so next we come about this particular mission. This is actually quite interesting. It is called the Hayabusa mission. So this Hayabusa mission was the first mission which was done by, first done by us, and in terms of, say, it was done by Japanese space agency to return a sample of material from the surface of a near-Earth object. So when we say near-Earth object, so here we mean an asteroid, as an asteroid, or so sort of a rock. So it was the first mission which was able to do that, and in that process, it was actually a 2-year journey to this particular asteroid, which is called Itokawa. I'm not sure if I'm pronouncing it correct, but this is sort of the naming process. So maybe it was Itokawa. So this was a 2-year journey to this particular asteroid by Hayabusa, and it was followed. It is currently being followed up by another mission, which is Hayabusa 2, which is currently in a mission and currently sending some amazing pictures from this particular asteroid, and not only that asteroid but other asteroids and other objects as well. So this Hayabusa mission was actually launched in May 2003, and it's currently now it's no longer in use. Now we have Hayabusa 2, which is following up the mission and studying these particular objects. So this so here I just highlight a couple of primary objectives which this Hayabusa mission was actually taking up, as to this is actually just some few objectives of this particular mission, but this in general follows up by every space mission which was done for these studying these rocky objects. As to when I say rocky objects here, I mean these small objects, which is asteroids and sort of comets. So the first objective is basically to conduct an interplanetary flight with a new ion engine propulsion system. So this, so as we know that whenever we want to do some space travel, something like Star Trek or something in Star Wars, right? So those massive space travel, those massive spaceships, they have basically sort of a propulsion system. The propulsion system is sort of like an engine, right? We need to have some sort of very heavy engine to propel it to travel in interstellar distances, to travel into such huge distances, as because space is quite big, and we need to travel a lot of distance. Like even the distance between Sun and Earth is quite a lot, right? It's billions and billions and billions of miles. So for that kind of thing, we need a different kind of system, different kind of propulsion system. So there is this new system which was developed using ion engine, and this was the first flight to actually test that particular this kind of system, this kind of propulsion system. Second, to perform autonomous navigation by determining its own location and landing on a target using its own calculations. So this was quite an achievement which was made by Hayabusa, basically, to do everything autonomous. So there are certain algorithms, there are certain sort of robotic systems which was placed on Hayabusa mission, and these days we know a lot about programming, about coding and stuff. So these things actually help us. So this is actually direct application that it was doing everything autonomously. It was calculating distance, it was calculating its own location, which is quite a big achievement in itself. And in the process of doing all this thing, it managed to do all these things and land on the particular asteroid. So this was quite a big achievement. And I don't know if you know this Apollo 11 mission, which was first done. So all the calculations which was done to take the rocket from Earth to the moon, all the calculations were done by hand. Each and every calculation of orbit and till the landing of the system. But here right now, what we are doing is we are transforming from manual to autonomous world, because this is something which will be quite necessary in future, and quite in the future world, because we are actually coming from a an era where everything was done manually, every small calculation. But now we have computers to do so, right? We have the big supercomputers, and there were certain computers which was coded in a particular way to find its own location using some basic astrometry, or it's a geodesy, which means nothing but in simple terms, calculating its location, and and even managed to land on this particular asteroid, which in itself is quite a big deal to do that. So to collect samples from an asteroid. This was one of the major missions, one of the major objectives of this particular mission, which I explained already, and also explain why is it important to actually collect all the samples from an asteroid, because obviously they're gonna help us understand more about these objects, where they came from, where they come from, and also how solar system or how that particular object must have formed. And then we have to accelerate through space using ion engines in conjunction with an Earth swing by. So I think I don't know if you might understand this thing, but in simple terms, if I want to explain it, so instead of just using engine, we will be using Earth's gravity as well. In combination of these things to basically accelerate into space. Why? Because in gravity, I don't know if you play these games, but there's this Angry Bird game, right? There's this Angry Bird in which you use gravity to basically shoot those birds, right? So something like that. We use gravity as a catapult sort of thing, as a sort of a thing, to basically throw something into certain orbits. So here we go. So here we use this ion engine plus the Earth's gravity to basically take a swing by and accelerate the speed, hence reducing the consumption of fuel from the engine and just using Earth's gravity to do that. So that actually helps a lot when when you do this thing, because for example, if you have some mission for landing on Moon or some doing some mission to Mars, so we use Earth's gravity to do that, to accelerate into space. This actually saves a lot of. So first one was founded on January 1st, obviously the new year, 1801, by astronomer Giuseppe Piazzi, some Italian person. So
It was initially was thinking that this was a comet,
yeah.
and but then he was able to find out that well, this is not something which is moving according to the motions of a comet. So उसका motion
Yeah.
comet की तरीके से नहीं था, and it was hence named something by what was the name of that scientist जिसने asteroid named किया था? I think I wrote it somewhere. I mentioned it. No. It was a Western person, a famous individual. Asteroid, the name came from Aster, as in जो मैंने कल talk में भी अपने बताया था कि Aster means star in Greek, or asteroid means star-like. So it's not a star, but it is, appeared to be star-like. I hope my voice is audible.
Yeah, I guess it's quite odd. I mean, there are multiple questions which are asking the same thing.
So many people are just asking ki how. ये दो तरीके हैं जिनसे हम मेजर करते हैं एस्टेरॉइड को. एक रेडार इमेजिंग जो फर्स्ट इमेज है, और जो सेकंड इमेज है दैट इज फोटोमेट्री या एस्ट्रोमेट्री, डिपेंडिंग. एक ऐसा ऑब्जेक्ट जिसका मोशन इन द बैकड्रॉप ऑफ स्टार्स बहुत अपैरेंट दिख रहा है, बहुत अपैरेंट मोशन दिख रहा है उसका, एंड इट इज नॉट यू नो उससे पहले प्री डिटरमिन्ड नहीं है वो ऑब्जेक्ट. We'll get into catalog and stuff. This is something which is a science, citizen science project as well. You can look up to various sites of NASA and stuff for the data.
There's this National Asteroid Search Campaign, IASC, I think, which most of you can actually participate in into searching of these asteroids, and that would be quite a good thing if you guys can use this thing as a starting base if you're interested in astronomy and want to discover your asteroids. So this is quite a big thing.
Yeah.
I guess.
Yeah.
So there you can use photometry as to as a method of detection to do these things. And so this is International Asteroid Search Campaign. So
any further questions, guys?
If there are any further questions, you can just ask in this
How
chat.
was the first? This is something that you can look up on Google. Giuseppe Piazzi was the first person who was able to discover, as we have already mentioned. आप एक बार Giuseppe Piazzi का नाम डाल के Google पे देख लीजिए कि how that particular thing was discovered.
Yeah.
Per se. And basically, asteroid awareness के लिए asteroid day हम मनाना चाहते हैं. सेलिब्रेट तो नहीं कर रहे हैं, बट हम अवेयरनेस के लिए एक ऐसा फंक्शन रखते हैं जिसमें वी इनवाइट मेनी पीपल ऑफ ऑल एजेस, एंड वी ट्राई टू स्प्रेड दिस न्यूज अराउंड कि एस्टेरॉइड जैसी भी कोई चीज होती है जो हमारी लाइफ पे इम्पैक्ट कर सकती है. जैसे अभी कोरोना वायरस के बारे में बहुत लोगों को नहीं पता था और कितना मेजर इम्पैक्ट किया उस कोरोना वायरस ने हमारी लाइफ पे, वैसे ही ये एस्टेरॉइड जो अपने कोर्स से थोड़ा सा भी डिस्कोर्स हो गया, अभी तक तो हम जितने ट्रैक कर रहे हैं, व्हाटएवर एस्टेरॉइड इज ट्रैकिंग, if they miss by some points, and if we are able to miscalculate some of their orbits, or if they collide with some other asteroid and then they are set on a disk course towards Earth, then eventually when they will collide with Earth, they will wreak havoc. मतलब पूरा ऐसा एक्सटिंक्शन होगा कि उस समय हम बच भी नहीं पाएंगे. तो कोरोना वायरस इज समथिंग दैट gave us at least a chance to survive. All of us are fighting in this moment of pandemic. But asteroid impact is something that जो साइंटिस्ट ने अगर उसको मिस किया है किसी एस्टेरॉइड के ऑर्बिट को ट्रैक करना, so that will be something hazardous not just for us humans, it will be hazardous for the whole planet. जो हमारी biology है वो on the face of this earth वो remove हो जाएगी from the face of this earth. So that is one thing that we'd like to emphasize on in this particular day. और एस्टेरॉइड डे से हम ये चीज को भी अवेयरनेस बता सकते हैं कि फ्यूचर में इफ वी विल बी सेंडिंग स्पेस मिशन, एज माय कलीग मेंशन्ड ओवर हियर, ये जो स्पेस मिशंस होंगे, ये नॉट ओनली दे विल allow us to technologically super overpower that particular asteroid. उस एस्टेरॉइड को हम अपने काबू में ला पाएंगे, but we will be able to extract so many minerals and so many other valuable elements from that particular asteroid, and also we will be able to study the history of our the formation of our planet. What were the constituent basic elements and the compounds of our of the early Earth system. Earth, because it is a dynamic system, यहाँ पे weathers है, अलग-अलग मौसम होते हैं, तो इस वजह से the impact, the history of the whole Earth formation is sort of has eroded, or these asteroids, since they are in the vacuum of space, so all of that information is preserved, right? So
So I guess we will take a couple of questions. There's a question: is there any asteroid which is bigger than Burj Khalifa?
So as I mentioned,
Here we have some comparisons which can.
so yeah, this is a comparison with Pluto and Charon. All the three of the above figures are sort of considered in the asteroid part of the objects in our solar system. So Ceres is typically not called as an asteroid, but
It's a dwarf planet.
yeah, it's a dwarf planet. It is consisting. Uh, I mean, it is sort of circular in shape, but it is largely located in the region of asteroid belt. So उसके size के comparison में उसका size is about 945 kilometers in diameter. And 945 kilometers is something that I'm emphasizing on. 945 meter नहीं है, kilometer. And Burj Khalifa की height I think 800 and something close to 900 meters है. वो 1 किलोमीटर भी नहीं है ना. So Eros जो है जो बहुत छोटा लग रहा है सीरीज के आगे या वेस्टा के आगे, it is about 16 point something kilometers. So can you imagine कि यहाँ पे कितना छोटा लगेगा बुर्ज खलीफा? It will not be even, you know.
Yeah, I mean, I should have quite comparison about this asteroid in Benu, which is around 510 meters, right? So this is the direct comparison of other, man-made objects such like Empire State Building or Eiffel Tower. So somehow you can just take a take a quite leap, like you can just make something bigger, like Burj Khalifa. So thoda sa bada, I don't think that maybe quite big. But so as mentioned that Eros and series is around 914 kilometers. 40 kilometers. And so obviously we can say that Burj Khalifa is not the tallest thing, but we have a lot of things which are quite bigger than that. So I think we can take a couple questions maybe.
Yeah. So someone mentioned why asteroids are called asteroids. Asteroids are called asteroids because the name suggests aster means star, and oid sort of means like star in Greek. Aster, basically the word aster hai, that also came from Persian, astar. And astar Persian, that word came from Sanskrit. So स्थिर जो ऑब्जेक्ट स्थिर रहता है स्काई में अपनी पोजीशन से ज्यादा मूव नहीं होता है उसको हम स्थिर बोलते हैं कि स्थिर है अपनी जगह। और स्थिर से पर्शियन लैंग्वेज में जब वो हमारे यहाँ इंडिया में आए सीखने के लिए तो उन्होंने अपने लैंग्वेज में अस्तर बोलना शुरू किया। फिर जब वही लोग जब ग्रीक रीजन में गए तो उन्होंने एस्टर बोला एंड एस्टर मींस स्टार लाइक ऑब्जेक्ट, एस्टेरॉइड मींस स्टार लाइक ऑब्जेक्ट। So that's the etymology of the word asteroid.
So there is, the most common question that is that how are asteroids made, right? That's a very common question. So it's like even when solar system was, just young, very, very young, when it was just forming around 4 billion years ago. So there were, all sort of rocks which were, coming into one particular sort of position, which is right sun. So when the sun was actually forming in this whole nebula, so the rocks with all these things which are quite left out, they started to form planets. And when the rocks which they fell out from those planets, which were not a part of those, planets, they actually started to, become these small rocky things called asteroids. And some of those objects like comets, which are, taking a huge orbit. So those are, orbits. Those are actually comets. So asteroids are something which, were formed in the starting of the, solar system when it was very young, when it was just formed.
So we'll probably take the last question, and then this is a cue for Prerna ma'am to take over. एक last question ये है कि someone just mentioned कि asteroid की अपनी magnetic field होती है. So depending on उसकी constituent क्या elements है, whether it is formed of some magnetic substance जो magnetized है, which is highly unlikely, and उसके core is not molten like the molten core of our planet. जिसके मोशन से फ्लक्स जनरेट होता है तो मैग्नेटिक फील्ड इंड्यूस हो जाती है, बट ऐसा तो नहीं होता है एस्टेरॉइड में. सो इट इज हाईली अनलाइकली कि किसी एस्टेरॉइड की अपनी मैग्नेटिक फील्ड होगी. सो दिस इज द लास्ट क्वेश्चन वी गोइंग टू टेक एंड Prerna ma'am, this is probably about time that we end our discussion over here.
Yeah, so hand over to you.
Yeah.
Presented at the online discussion hosted by the Nehru Planetarium. Thank you for coming and thank you for joining in. Some of the questions were really very important. I think the guest has answered them all, and probably some which are left. Apologies for those. We can answer them if you can give us a mail on the Nehru Planetarium. The ID is planetariumprogram@gmail.com. We're probably going to answer your rest of the questions there. So because of the time constraint, we have to stop this discussion here. Thank you, everyone. And thank you, Saurav and Siddharth, once again.
Hello.